S'il vous plaît, ابعثوا للزملاء تاعكم لو ليان بور باش يبارتيسيبيو.
Monsieur الباترون لو ليان.
اه، نورمالمون بعثت لهم انا لو ليان، ما على باليش اسكو ما على بالهمش بلي هذا هو ولا لا.
احنا لازمك نعاودو.
دونك اون فا كومونسي. اللي الحق اللي ما لحقش يتبع لا فيديو في اليوتيوب وخلاص. Alors, la dernière fois, nous sommes arrivés à l'exercice numéro, donc dans la série numéro 3, حلينا les exercices de 1 jusqu'à l'exercice 8. 8, دركا نحلو l'exercice numéro 9. Alors, on a une fonction f de x définie comme suite. F de x est égal à x fois sinus 1 sur x cx if x is equal to 0 and it is equal to 5 if x sorry, here is when x is different from 0 and it is equal to 5 when x is equal to 0. The graph of this function will be like this. Here the x, this is the graph of y equals x, and this is the graph of y equals minus x. Here we have the value of x times sine 1 over x. Notice that when x approaches 0, 1 over x approaches infinity. In this case, the sine of 1 over x will oscillate between the two values of plus 1 and minus 1. So, when approaching 0, the function will be something like this. Between those two lines. But at 0, we have the image is the image of f of x is equal to 5. Here this is f of 0. Now is this function is continuous at the point when the point is equal to when x is equal to 0 here. Here the function jumps from 0 to 5. From the graph we see that this function f is not continuous at x equals 0. So the question of this exercise is show using the definition of limit f of x is equal to 0. Show using the definition that this limit is equal to 0, then deduce that f is not continuous at 0. Then deduce that this function is not equal at 0, and can you define f of 0 such that the function f will be continuous at x equals 0. Here we simply so to show so here one show that f of x is tends to 0 as x tends to 0, or equivalently the limit when x goes to 0 of f of x is equal to 0. Here we have so the exercise says using the definition show using the definition. Sorry. So we have sine 1 over x is between 1 and minus 1 for every x different from 0 and x is any real number. Now by multiplying by x, we find that minus x is less than x times sine 1 over x, which is less than or equal to 1 times x. Then introducing the limit in all sides, we find that the limit of minus x is less than or equal to the limit of x sine 1 over x, and this is less than or equal to the limit of x. All of this when x is going to 0. Also, this is going to 0 and this is going to 0, which implies that this limit of x sine x 1 over x is equal to 0 as x approaches 0. So this proof is using this is the end of proof, and we call this the squeeze with theorem. But the exercise tells you using now we will use another approach, which is using the definition. So to use the definition, the proof of limit of x tends to 0 of f of x is equal to 0 using the definition means that for every epsilon positive there exists delta positive, such that for every x, if x minus 0 is less than delta, then this implies that the function f of x minus 0 is less than epsilon. So how to do this? This is very easy. So let epsilon a positive number. Now we have so f of x minus 0 less than epsilon means that x times sine 1 over x is less than epsilon. But we know that sine 1 over x, the absolute value of sine 1 over x the absolute value of sine 1 over x is less than or equal to 1. So x times sine 1 over x is equal to the absolute value of x times the absolute value of sine 1 over x, which is less than, using this inequality, which is less than the absolute value of x. Hence, if this value, which is less than or equal to epsilon x, is less than epsilon, so here if then then f of x minus 0 is less than epsilon. So the absolute value of x less than epsilon, this is equivalent to x minus epsilon 0 is less than epsilon. So we take delta equal to epsilon. Hence, if x minus 0 is less than delta, which is in this case equal to epsilon, then f of x minus 0, which is equal to x sine 1 over x, is less than or equal to the absolute value of x, which is less than epsilon. Hence, by definition, limit of f of x is equal to 0 when x goes to 0. Now, the next question tells you deduce that f is not continuous at x equals 0. So, now deduce that f is not continuous at x equals 0. How to do this? To say that f is continuous at x equals 0, we must have that the limit as x approaches 0 of f of x is equal to f of 0. But in our case from question 1, we have the limit of f of x is equal to 0 as x approaches 0, and f of 0 is equal to 5. So the limit of f of x does not equal to f of 0. Therefore, the function f is discontinuous at 0. Now we move to the next question, which tells you, can you define f of 0 so that the function f is continuous at x equals 0? So the next question is, can we define f of 0 so that f will be a continuous function? Function. Okay. Here, for f to be continuous, we must have limit of f of x is equal to f of 0. So since limit of f of x is equal to 0. So f of x, f of 0 must be equal to 0, not 5. So we define f as, we define f like this: f of x is equal to x sine 1 over x when x is equal is different from 0, and 0 if x is equal to 0. So this is the answer to the to question question B. Now we pass to the next exercise. Is there any questions till now؟ اسكو عندكم أسئلة لحد الآن؟ So the next exercise is study the continuity of the following function. So now here we have a question. Here, study the continuity of the following functions. Study of the following functions. So the first function is f of x is equal to x plus cosine x all squared. So the first function is here f of x is equal to x plus cosine x all squared. Sorry, I made a mistake here. The floor function of cosine x. Here x is in the interval from 0 to p, 0 to p, and this is the floor function. Here we have the floor function of sine x. So how to solve this exercise? So to do this, we must divide our interval from 0 to p to some intervals where the floor function of cos x is equal to 0 or 1 or minus 1, depending on the values of x on this interval. So here we will have the following. So here we have three values of cosine x. So the floor function of cosine x will take three values, either 1 and this is either 1, and this is when cosine x is equal to 1, or 0, and in this case where cosine x is in the interval from 0 to 1, and minus 1 if cosine x is in the interval from negative 1 to 0 open. When x is equal to 1, this is exactly when x is equal to 0, and the second case is when x is between x is in the interval from 0 to p over 2 closed, and the third case is when x in the interval from p over 2 until p. So in these three cases, the function cosine, the floor function of cosine x takes the value 1, 0, and minus 1. So here we will calculate the function. So f of x will take the values 1 plus x, here 1 plus x all squared. So before doing this, we must discuss case by case. So here, if x is equal to 0, then cosine x is equal to 1, and in this case f of x will be equal to 1 plus the floor function of 1 squared, which is 2 to the power of 2, which is equal to 4. If now x is in the interval from 0 to pi over 2, then cosine x will be in the interval from 0 to 1 open, which means that 0 is less than cosine x is less than 1, and in this case the value of cosine x will be equals to 0. So the function f of x will be equal to x plus the floor function of cos x all squared. In this case it is equal to x plus 0 all squared, which is x squared. Now we have the and therefore when x sorry, before doing so we will write our function. So if x now is in the third case, which is in the interval pi over 2 to pi, so the function cos x will be in the interval from minus 1 to 0, that is here we have minus 1 is less than or equal to cosine x, which is less strictly than 0, which means that the floor of cos x is equal to minus 1. In this case, our function f will be defined like this. F of x is equal to x plus the floor function of cos x all squared, which is equal to x plus 1 all, sorry, x minus 1. X minus 1 minus 1 all squared, which is equal to x squared minus 2x plus 1. So we've defined, now we give the full definition of the function f. So f of x in this case will be equal to, in the first case, for if x is equal to 0, then it is equal to x squared if x is in the interval from 0 to p over 2, and it is equal to x minus 1 all squared if x is in the interval from p over 2 to p. Now we will check, the question is study the continuity, so we will see whether our function f is continuous or no. So in both three cases, if x is in the interval from 0 to p over 2, and if x is in the interval from p over 2 p, we have x squared and x minus 1 all squared are both continuous. So f is continuous inside those intervals. Now we will check whether f is continuous at the extremities of those intervals. So here we will calculate the limit when x approaches 0 with greater values of the function f of x. In this case, x is in the second interval from 0 to p over 2. So the function will be equal to x squared, as x is approaching 0 with greater value, which in this case is equal to 0, which is different from f of 0, that is equal to 4. Hence, f is discontinuous at x equals 0. Now the next case is when x approaches p over 2 from the left and the right. So the limit when x approaches p over 2 with the from the left of f of x, here in this case x is in the interval from 0 to p over 2. So the values of f will be x squared. So here the limit when x approaches p over 2 of x squared, so in this case will be x p over 2 to the power 2, which is p squared over 4. Now next, the limit when x approaches p over 2 with bigger values of f of x, here x will be in the interval from p over 2 to p. So in this case the values of f of x will be x minus 1 all squared. So replacing x with p over 2, it becomes p over 2 minus 1 all squared, which is equal to p over 2 over 4 minus 2 times p over 2 plus 1, which is p over 4, p squared over 4 minus p plus 1, which is different from from the limit when x. So here we notice that limit when x goes to p over 4 of f of x with from the left is different from the limit of f of x when x approaches p over 4 from the right. Here it is equal to p over 2 minus 1 squared, and here it is equal to p squared over 4. So f is discontinuous discontinuous at x equals p over 4. Next, the remaining point is if x limit when x goes to p, here with from the left, because the x approaches p from the right, it is not defined. So of f of x, which is equal to the limit when x approaches p of x minus 1 all squared, which is equal to p minus 1 all squared, which is equal to f of p in this case. Hence f is continuous at the point x equals p. Now this is the study of continuity of the function f of x equals x plus the floor of cosine x all squared. Is there any questions؟ قبل ما نفوت لا question suivante، هل يوجد أسئلة؟ Now we move on to the next function, f of x. Here in this case is equal to x to the power p. So here the next question is f of x is equal to x to the power p times sine 1 over x if x is different from 0, and equals alpha if if x is equal to 0. So how alpha is any parameter that belongs to R. Here discuss according to the values of p and alpha the continuity of the function f. So here we will study the continuity of f depending on alpha and p. So the continuity here, notice that for any values alpha and p, when x is not equal to 0, then these functions are continuous. Here p is a natural number. So notice that when x is different from 0, f of x is simply equals x to the power p sine 1 over x, which is a composition of continuous functions x to the power p and sine x and 1 over x, which leads to f is continuous on r minus 0. Now what remains is check whether f is continuous at x equals 0. So we must find that the limit of f of x is equal to f of 0 when x approaches 0. Here in this case, from the definition, f of 0 will be equals to alpha, so which is equal to alpha in this case. Now the limit of f of x when x goes to 0. So in this case, our function either with the smaller values of x or bigger values of x. In this case, x is different from 0. So it is equal to the limit when x goes to 0 of x to the power p sine 1 over x. In this case, so this limit using the equivalence theorem, by equivalence, so this is equivalent when x approaches 0 to the limit of x approaches 0 of x times p to the power 1 sorry here uh, 1 over x does not have a limit sign, so in this case the limit simply is equal to 0. So the question here: study the function, discuss according to the values of p and alpha the continuity. So the limit here is simply